Statistics, like other branches of math, uses variables. Now, on the data collection side, however, they use the word a little differently. To a researcher or a pollster, someone whose job involves collecting data, a variable represents the thing that they're trying to study. For example, if you're studying the growth rate of kids, then you would probably have two variables, height and age. On the other hand, if you were studying something like color blindness, then you might just have a single variable, whether or not a participant in your study has the condition. Now, I have another example on this slide where a city is trying to determine how long drivers are waiting at stoplights. So they send out monitors to time the wait times at 20 different stoplights around the city. So thinking about this proposal, what would be the sample, the population, and the variables involved? Now remember that the sample is always going to be the group of things that are being observed or questioned. So in this scenario, that would be the 20 stoplights, the 20 intersections that the observers are sent out to. The population, on the other hand, would be the set of all stoplights in the city, the set of all intersections. That is the larger group that the sample represents. So for this scenario, we're only going to have one variable. That would be the time interval that cars wait at each light. For example, 1 minute, 2 minutes, 1 minute, 45 seconds, etc. Now, this scenario was a little more complex than the previous one. This researcher wants to study the effectiveness of several insecticides. So the sample here will be the three groups of plants that are being treated. And the population will be all the plants of those types. Now with something like this, it's important to be specific. It would be a mistake to assume that the population will be something like all plants. For example, if the study only included strawberry plants, you wouldn't want to try to extend the study's results to something like raspberry bushes. There might be a type of bug that's common on raspberries, but that's unaffected by any of the insecticides in your study. So your study wouldn't give you accurate information about its effectiveness on raspberry bushes. So the rule here is that it's best to define your population as narrowly as possible to avoid exaggerating your results. Now, for the variables, this scenario has two. The first one would be the pesticides used, and the second would be the number of insects on the plants. Now, notice that I didn't include the types of plants being used in the study. When you're thinking about variables, you should keep in mind that they have to be something that can take on different values. For example, the pesticide used will be different for each group, and the number of bugs will be different for each group. The type of plant, on the other hand, won't change. It's going to be the same in each group, so that wouldn't qualify as one of our variables. Now that we've seen some specific examples of variables, I want to talk about the ways that variables are classified and why those classifications are important. At the highest level, variables are broken up into two categories, quantitative and qualitative. Quantitative variables are variables whose values are numbers that represent counts or measurements. That last part there about counts or measurements is important. Not every numeric variable is going to qualify as quantitative. And we'll see some specific examples of that on the next slide. Now, on the other hand, are the qualitative variables. These are variables that represent names, labels, or descriptions. For example, colors or opinion ratings like high or very high. Now, the way I remember these two is to think of them as quantitative variables represent quantities, or numbers, where qualitative variables represent qualities, like color or opinions. On this slide, I have some examples of different variables, and I want to categorize them as either qualitative or quantitative. So to do that, the first thing I want to do is think about some of the possible values for each variable. For example, rainfall levels could be 2 inches or 3 inches. The number of books read in the last month could be 3 or 5. A person's best book read would be a book title like City of Glass or The Shining. And finally, jersey numbers would be things like 10 and 22. Now, the ones that are non-numeric are always going to be qualitative. So the best book read is going to fall into that category. And for the numeric values, we have to think about whether or not the numbers represent counts or measurements. Now, the first two variables fall into that description. For example, the rainfall values are heights, and the number of books read are counts. Jersey numbers, on the other hand, don't represent either of those things. So, despite being numeric, these values are going to be qualitative. When I'm making this distinction, the question I ask myself is, if I average the numbers, does that tell me anything? With rainfall and number of books read, the average rainfall and average number of books are meaningful numbers, so those values go in the quantitative category. On the other hand, knowing the average jersey number of a team doesn't tell me anything about the team or the jerseys, so those values would be qualitative. A second way that we classify data is by whether it's discrete or continuous. A discrete variable is one whose values are either finite or countable. A continuous variable is one whose values are infinite and not countable. Now, that countable word is a little tricky. It has a technical definition from set theory that's really more complicated than we want to get into here. In the statistics textbook, authors go to a lot of trouble trying to come up with a non-technical definition based on whether you can count the number of possible values. Now, I'm going to try to simplify that by giving you a few simple rules you can apply. If the number of possible values is finite, then the variable is discrete. As an example of this, think about a person's favorite color. There's a finite number of possible responses, so that would be a discrete variable. Now, if the possible values are all integers or fractions, then the variable is discrete. For example, the number of books a person finished last year. The possible values are all going to be integers, so this would be a discrete variable. If the possible values are a limited number of decimals, then the variable is discrete. This category is a little tricky. An example would be dollar amounts. They aren't integers or fractions, but there are at most 100 possible values for the cents part of a value, so the number of possibilities are still limited, which puts this in the discrete category. And finally, if the possible values don't fit into any of those categories, then the variable is continuous. And an example of this would be a variable like the speed of an object that can have an unlimited degree of accuracy. So I put a few more examples on this slide for us to think about. Why don't you pause the presentation and think these through on your own. Try to put each of them in the discrete or continuous category. Then start the video again and you can see how I categorize them. So the number of days an employee was late for work in the previous month has a finite number of values. It's going to be at least 0 and at most 31. It's the maximum number of days in a month. So this is going to be a discrete variable. Rainfall levels can have any decimal value, for example 1.2 or 1.2661 or 1.559291. So this is going to be a continuous variable. Now, you might be inclined to try to categorize this as discrete because the tool that you use to take the measurements is only going to have a limited accuracy. For example, it can only go out to 2 decimal places or 3 decimal places, which makes it look like the number of decimal digits is limited. Well, when you're making this kind of determination, you shouldn't take into consideration the limitation of the tools you're using to get the data. You should only think about the actual possible values that the variable can have. Now, the total purchase cost of purchases made in a store are going to be dollar amounts. These are decimal values, but the decimal values are going to be limited to 2 digits. So that puts this in the discrete category. And finally, patient temperatures are going to be limited to a certain range, but within that range, they can take on an unlimited number of values. For example, 98, 98.1, 98.225, 98.26221, etc. So this is going to be a continuous variable. On this slide, I've laid out the 4 categories that we've discussed so far in a kind of hierarchy. Variables in general can be divided into qualitative and quantitative. And quantitative can be divided further into discrete and continuous. Now, in practical terms, the major difference between the 2 groups is that you can do calculations like averages with the quantitative variables, where you can't with the qualitative variables. For example, think about trying to average word values like colors or true-false responses like yes or no. It's not something that obviously you can do since they aren't numbers. So that's going to be the big distinction here between these 2 types. So in the next video in this series, we'll go into more detail on different levels of variables and what limitations there are on the things we can do with them, even within the quantitative category.